Okay, let's get started. We want to share with you the experience of testing Scylla database. We basically put Scylla in production and to see how it performs with comparison to Cassandra database. More details to come. Let's start with the beginning. My name is Szymon, I'm a systems administrator. This is Lukasz. This is Łukasz, database administrator. We work for Allegro. A quick look at the agenda. A few words about our company, how we use Cassandra, why we started using it, what problems we have with Cassandra, the infrastructure we use, and why we decided to test Scylla. And of course, the results of the tests.
Okay, few words about Allegro. It's a well-known company in our country, so just few words and some numbers. We started in 1999 as an auction site, and now is the biggest e-commerce company in Poland and one of the biggest in Europe. Allegro is a shopping destination for 14 million users monthly. We have over 200 million visits per month, and about more than 750,000 items are sold daily.
Cassandra. About Cassandra, a few words about Cassandra, why we started using it. Well, it was open source. It was created and open sourced by Facebook 10 years ago. And the next year, it became part of Apache Incubator project. Currently, most of the commits are committed by a company named DataStax. They, by the way, create a paid enterprise version that consists of Cassandra, Spark, Solr, monitoring tools, backup tools, a lot of additional extras. In the picture below, you can see a single. That's how we represent a Cassandra cluster. It looks like a ring. Every circle is a single node. It's a single server. It could be a physical server or any form of virtual server. Key features of Cassandra. Why we decided to start using it. First of all, it's a distributed database, and it's masterless database. So, for example, with MongoDB, you have primary servers, secondary servers, you got config servers, routers, a bunch of different functions on different machines. In Cassandra is masterless. That means that all nodes are equal. It doesn't matter which server you write to, doesn't matter which server you read from. You can connect to any node and do the things you want to do. The next one, fault tolerant. By default, you can lose a single machine and a single node in a cluster, and the cluster keeps running. The database is okay. There are no errors. Everything is working fine. Of course, you can tune some parameters to be able to lose 2 nodes or more. But it's one is enough. So it doesn't matter if it's a hardware error, human error, software error. What else? Linear scale performance. So if a single Cassandra node can handle 5,000 requests per second, then if you create 4-node cluster, it gets 20,000 requests per second. Again, if you want to double the throughput, you add extra nodes. And all of those things can happen online. There is no downtime. New nodes join automatically. It works really good. And last but not least, active-active. Well, you get replication by default. There is, you don't have to play with you don't have to do any additional steps. DC1 in this example has exactly the same data as DC2. So you can even have active-active applications, which means that you can write to one data center and read the data from the second data center. It's all working automatically by default. Well, actually, we use active applications, the ones that some clients write to one DC, other clients are writing to the other DC, and it's working fine. Well, in this case, you can lose, for example, one node in first data center and one node in the second data center, and it still would be working fine.
Okay, let's talk about Cassandra at Allegro. We started using Cassandra about 5 years ago or 6 years ago. Our first cluster was installed on bare metal machine, and it was a 12-node cluster in both DCs, so 6 per 1 DC. And in a short time, we saw that we've got a lot of key spaces and a lot of tables in this cluster, and it met us to some problems, performance problems, because when you have some tables with a lot of tombstones or with big partition, performance problems from one table, one schema, can affect entire cluster. So the next step was switch to Linux containers, and it simply separate CPU, memory, network cards, and this configuration we still using. We use Cassandra in many areas. In financial recommendation, it's storage for monitoring tools, and we also written own solution audit log. This is because of our internal need company. Okay, and maybe some numbers. For now, we have 20 clusters, and this is it's about 250 nodes at all. In peak traffic, we have about 250,000 operations per second. Most of those operations are read operation, and cluster size we've got from 8 to 70 nodes in both DC. In Allegro we have SLA. It means that our cluster have to respond in time no longer than 100 milliseconds.
A few words about infrastructure. We use 2 data centers, and a typical Cassandra node, as Lucas said before, a container consists of 8 to 12 virtual CPUs, 32 gigs of RAM, and one locally attached dedicated SSD drive. The only thing shared between containers in a single physical machine is a 10 gigabit network connection. As for the software, well, as you can see, we use Ubuntu with Cassandra 2.1. G1 is our garbage collector, and the heap size varies depending on the cluster between 10 and 16 gigs. We use Puppet for deployment, standard set of Grafana, Tessera Graphite for monitoring. We have a bunch of scripts for monitoring tombstones, big partitions, to let us know if something bad happens. We use PagerDuty for waking people up in the night, and there is a tool called Cassandra Pinger that it's our internal health check. It constantly monitors all the clusters and let us know if something is wrong. What else? We try to use one cluster per service. We use all possible compaction strategies with Cassandra. Full repairs run during the nights. As Lucas said, we have internal audit log, and backups are done every 3 hours.
Okay, and about some problems we met with Cassandra. The first one, I think many of you will know such log. It's JVM. It's a log from JVM from Cassandra. As you can see, there is a lot of GC poses, and it means that sometimes single Cassandra node have to wait 1 or even 2 seconds because of GC poses. So that's the first problem. Oops. Okay. Another thing is maintenance task, because we have a lot of key spaces, a lot of databases, and very often we have to migrate some data from one cluster to another cluster. Very often we have to resize our clusters. So very often we have to do some joins or remove nodes or do some restarts, cleanups, and so on. Of course, we have some automation tools for this task, but it takes time. Another problem is a lot of latency spikes in Cassandra. In next slide, I will show you from our production traffic how it's look. So that's the problem, and such operation like joins or cleanups, repairs may really have serious impact to production, to our cluster, to performance of this cluster. Another thing is that a lack of documentation. Very often we have to look into Jiras or even into code of Cassandra to see how it works. And we started looking for some solution for that. We found Scylla project. It's just drop-in place replacement for Cassandra. It's able to read data files written by Cassandra, and it's written in C++. Scylla is written in C++. It's using C-stars network, and after we decide to install this database and check performance. And about test and results, Simon.
Okay, so you decided to do 2 kinds of tests. The first part was, we call it maintenance task performance. They include node joining, that means adding a new node to a cluster. Node decommissioning, that means removing a node from a cluster. Cleanup, that means cleaning up unused data from a node. And repairs, that basically corrects inconsistencies between replicas. And the other part of the test was putting a Scylla cluster in production with a Cassandra cluster of the same size and see how it performs. So let's take a look at the results. Okay, here is our setup. We use 3 and 3 nodes for both Scylla and Cassandra. They were running on exactly the same hardware, so it was the same amount of memory, the same type of CPUs, and every node was loaded with around 300 gigs of data. Okay, repairs run every night. They correct inconsistencies between replicas. And here is the first result we've got with the configuration I mentioned before. So it's 1 hour against 2.5 hours. So Scylla wins this one. The next one, decommission. That means removing a node from a cluster. When we want to make a cluster smaller, we want to remove a node to use it somewhere else, for example. Here's how much time it took with our setup. So it's half an hour against over 3 hours. What else? Cleanup. cleaning up unused data. When you, for example, add a new node to a cluster, it gets new data, but the old nodes don't remove old data. That's when we use cleanups to free up some disk space to remove unused data. And again, 22 minutes against half an hour. And the last one, adding a new node to a cluster. 45 minutes against over 3 hours. So in this part, we use those tasks quite often, and we always have to wait. There is nothing we can do. We cannot add 2 nodes at the same time. We have to add 1 node, and then when it's done, we can start adding another one. So the difference here is huge.
Okay, the second part is about putting Scylla and Cassandra into production traffic. There's a lot of benchmarks on internet with comparison between those databases, but we decided to test on our traffic. So we've got on the bottom we have our production Cassandra clusters, and in the middle there is test Cassandra cluster and another test cluster with Scylla. Those 2 clusters are running on separate machine, but on the same hardware configuration and the same number of nodes. And all those clusters are reporting metrics to Grafana and to our Pinger health check tool. First result, it's percentile P95, and this is peak hour in our company. It start in the evening, and you can see that first Scylla latency is very stable and below 20 milliseconds. On Cassandra graph, you can see a lot of spikes and very high response times. Another thing is P99. We are using in Cassandra. We measure P95 in Cassandra. In Scylla, using Scylla, it's P99 is usable, and you can see big differences between those 2 clusters. That's the same traffic. Another thing is speculative execution. It's simply a number of retries from application to cluster because of some lack or too long response times from cluster. And in Cassandra there is a lot of retries from application because Scylla is responding in very good time. There is a few, no more than 10, I think, in per second. Next case is we measure CPU usage, and Scylla is also use let's say less hardware resources. On the end, Cassandra graph is falling down. This is because we have to simply switch off this cluster because of too high response times. And you can see the moment of power off or redirect traffic from Cassandra test cluster to Scylla. And as you can see, Scylla was able on the same hardware process 2 times bigger traffic, and for the next 3 days we observed that we are able to process more than 120,000 operation per second. And the comparison between Pinger health check. And quick recap. After our test, we know that a single Cassandra node is able to process about 5 to 6,000 operations. When on the same hardware, Scylla is able to process about 5 times more, 20 to 22,000 operations. And comparison between P99, P95. Okay.
Yeah, so after reviewing the results of the test, it became clear that we can reduce number of Scylla nodes in a cluster. So during our test, Scylla was able to handle 120,000 requests per second, and we had to shut down Cassandra cluster at around 40,000 requests per second. And based only on this, and the test was made in production, so we couldn't get even more from Scylla. Anyway, based on only this test, we can safely reduce number of nodes by 3. What I want to say is that instead of we can replace 3 Cassandra nodes with a single Scylla node, and we still would be getting much better response times, especially at P99. HRP, hardware reduction plan factor, equals 3. That's what I've just said. So, for example, our 44 node cluster can be reduced to 16 node cluster, and we still be getting much better response times. Okay. Now here are some notes if you'd like to try it. What we think. HRP factor of 2 is a good starting point. So you can start with just putting half of the nodes to your new cluster. What you should think about is hardware limitation. For example, in our case, it was the number of physical drives in a single physical server. And one more thing, we cannot reduce number of nodes in a cluster below 4 in 1DC. That's because of replication factor equals 3. If we want to be able to lose one of the nodes and still have the cluster working.
Okay, and the last thing in our presentation, well, we still waiting for some feature from Scylla. It's hinted handoff mechanism and lightweight transactions. So the performance in our environment looks very good, but still waiting for some features we need in our environment. Okay, thank you.
Okay, do you have any questions? Okay, the questions was about repairs, how often we run it, and if we run full repairs, because some time ago incremental repairs were introduced. However, we are using version 2.1 of Cassandra, where incremental repairs, I think, are not really recommended. That's why we run full repairs, and we run it every night. We try to run them on 1 or 2 nodes at a time per day. Now there is a parameter in config files called, it's set to 10 days by default. That means that every node needs to be repaired not longer than every 10 days. So we keep it one node per day. In bigger cluster, we make it 2 nodes per day in a single DC. Yeah.
Compaction is it's automated by Cassandra. Let's say it depends how many data is written to database, and it's working. It's managed by internals of Cassandra.
I think we did.
You have control how many process or.
I think we did some tuning, and by setting compaction throughput to 0,
and
increasing the number of threads.
Three threads of compactions.
Yeah, so we are able to repair a single node in a couple
now
of hours.
we talk about compaction. Yeah.
Oh, no problem with it. I mean, after.
So throughput is set to 0, and the number of threads is 3.
We are able to do this in, I think, below 6 hours. So, yeah.
Well, first we was waiting for Scylla, and I think it was last year. I know that Scylla version 1.7 was compatible with SSTable 2.1, and that was the case. We still use Cassandra 2.1, but yeah, we know that this old version, and we will try to migrate to newer version. Excuse me? No. No, we just test Scylla and waiting for hinted handoff and lightweight transactions. For now, rather not.
Well, we find it quite surprising that they delay to introduce hinted handoffs because it's quite important. I mean, without it, we have to run full repair after every restart. But if we had any problems like losing data, corrupted data, I don't think so. I think we even tried to. What we did on some nodes was we did service Cassandra stop, service Scylla start on the same machine, and it worked fine. It was able to read Cassandra's data and respond the query. So I don't know if we had any problems with Scylla.
There was a few weeks of tests in production, and I don't remember any problems.
We can see on Scylla blogs that they are finding some problems and repairing them, releasing new versions from time to time, but we didn't have any problems in our tests. So it looks good.
Thank you. So how do you take backups in Scylla in comparison to Cassandra? And how do you restore them?
We have HKB tool, and because storage is the same, the same mechanism of creating SSTable, we can do it in the same form like in Cassandra, just copying SSTable using rsync, and it's a bunch of scripts that copy to our backup
the
server.
same question about repairs. Do you use same tool for repairs, and does it work just like that?
Excuse me?
Well, repairs are scheduled by Puppet, and we just schedule them and they run. And when it comes to backup, we started with classical copying files over NFS, but then we had to, because of the amount of data, it goes into hundreds of terabytes. We wrote a customized script. Well, it's not a script, it's more of a program now. Anyway, it uses rsync. It logs the backup files so that no one could read them, like delete them or connect to that server. And restoring is quite simple because
you have to just copy the files back.
Yeah, so we can use those scripts to copy them on servers and start Cassandra, or we can use old school. The tool is called as a stable loader, and it's default in Scylla for smaller database. It would work faster.
When you have a lot of data, simplest way is just copy data files.
So last question from me. Cassandra has a rich environment of tools around it, and many of those tools actually runs through JMX. And how does compare JMX output from Scylla and JMX communication from Scylla and that in Cassandra? So is it really like two different things?
You said about those graphs were done from application side. So it was response times from application, not from internal of Scylla or Cassandra.
Okay, so maybe I gonna ask this another way. We've got integration through JMX, for instance, Datadog for graphing some performance of Cassandra. And would it work just like that if we switch to Scylla?
Actually, Scylla wrote something that pretends to be Java listening, and they are changing that quite often. But basically, you can connect with all those things talking to JMX and see what's going on. However, it's changing so quickly that you would have to check what you can get from it there. But we were able to see some internal data. What's interesting about Scylla is that to see some statistics or to see what's going on inside, you can use REST API and just get with curl, for example, to see what's going on.
Okay, thanks.
Okay.
One more.
In this case, we used replication factor 3, I think. It was a few months ago. And consistency, it depends. Read with 1 and write 2 or quorum.
That's a good question.
It was, it was.
But are you asking about this test or in general? Oh.
In general, we use minimum replication factor 2, sometimes 3, and consistency level. Generally, we application read with 1 and write with quorum, sometimes each quorum.
We have a lot of combinations. Usually with replication factor 2 comes a consistency level of 1, and with replication factor 3 it's quorum. Well, the principles are the same. So yes, you need to schedule repairs and run cleanups periodically. What's good about Scylla is they call it, and it really works like this. They say that Scylla is self-tuning, so you don't have to play with number of threads, the amount of memory for heap, a bunch of stuff you don't have to touch, and you just switch it on, and that's it. I mean, repairs and cleanups still needs to be run manually. Okay.
I've got a question. Did you need to adjust the operating system to run Scylla, or is it just a drop-in?
I think we used Ubuntu 16, so there was no need for us to. I think we didn't touch operating system at all because of Scylla.
Okay, great, thanks.
Yeah. All right.
Okay.
Okay. Thank you.
Thank you.